In this video, I'll show you how to turn regular REST API into MCP tools for AI agents such as Antigravity using Apigee. We'll start with a quick look at Antigravity, where the agent can discover and use weather tools through the MCP. Then we'll look at the OpenAPI specification behind the weather API and see how Apigee sits in the middle between the AI agent and existing REST backend. After that, we will test the generated proxy using MCP Inspector and finally connect it to Antigravity CLI to see how the agent can use those tools in real prompt. If you're not familiar with Apigee, you can also check out our course where we cover both fundamentals of Apigee and newer Agentic AI and MCP use cases. Imagine you want to ask Antigravity something like, what are the weather alerts in the Pacific Ocean? And instead of calling a REST API manually, the agent discovers the right MCP tool, calls it through the Apigee, and gives you natural language response. That is exactly what we are going to see today. Here's the architecture. The pattern is simple: MCP in the front, REST in the back, and Apigee in the middle for governance, security, and visibility. The API agent connects to Apigee using MCP and JSON RPC. Apigee then transcodes the request and calls the existing enterprise REST API behind the scenes. There are two main Apigee patterns for this. The first one is the Apigee native MCP Discovery Proxy. We already have a separate video where we use the Apigee MCP Discovery Proxy to create an MCP server for Claude. This gives you native support and out-of-the-box functionality from Apigee. We also have a separate example showing how to connect MCP with Gemini Enterprise. In this video, I'll focus on second pattern, a custom MCP proxy generated from OpenAPI specification using Apigee Go-Gen application. With this approach, you have more flexibility. You can generate custom MCP-style proxies, customize the behavior, and deploy them using your existing Apigee capabilities and entitlements. The trade-off is that the approach uses custom logic, for example, JavaScript policies, which can add a small amount of latency, typically around 5 to 10 milliseconds. Now, let's jump into the demo and see how this works end-to-end. Have the tool called Apigee Go-Gen. In this tool, we have a template that basically allows you to take an OpenAPI description for a REST API. You take this OpenAPI description and basically you feed it to the tool, and using this MCP template, it transforms the OpenAPI description into API proxy in Apigee. And this API proxy behaves as if it was an MCP server. You can take this API proxy, deploy it to the Apigee runtime, and then get the URL for the proxy, and right away connect it to it from the MCP agent. Alright, so with that said, let's go and jump into the demo itself. So for this demo, I have an OpenAPI description for United States Weather Service API. And just really quickly, let me go ahead and grab the description for this and show it to you what that looks like. I'm gonna paste it into the Swagger editor. And you can see there are a lot of operations in here, right? Most of them are GET calls, but there is also a lot of operations. And there are schemas as well. So how this works? The way it's gonna work is that once I provide the tool with the OpenAPI description, for each of these operations right here, each of them is gonna become an MCP tool. And the name of the tool or the ID of the tool is gonna map to the operation ID. That's defined in the OpenAPI description. Similar for the inputs and the outputs. That tool takes, for example, this alerts operation takes certain parameters, and it produces certain output. All of that is gonna be coming from the parameters that are defined for that operation, such as query parameters, any header parameters, and also the body. And for the body, that's typically defined as a schema down here in the OpenAPI spec. So basically information, all of these operation IDs, the parameters, the schema for the inputs, the outputs, and using that to basically create a tools list that describes an MCP server. And let's go ahead and actually see how it works. All right, so let me go my demo here. The first thing we are gonna do, we are gonna run the actual tool. And the input to the tool is going to be the template itself that has the instructions and how to do this transformation. And also the OpenAPI description that I just showed you. And I'm also setting other information, like what is a base path for the API proxy that generated. And finally, the output for that. So let's go ahead and actually run it and see that. So we'll run this. Here we go. It was just taking a little bit of time. All right, so the generation just happened. And you can see the output right here. That's a zip file. This is the API proxy that was just created. And I'm gonna deploy this to my Apigee organization and to an environment that I have. I'm gonna use the Apigee CLI to do this. Let's go ahead and run this. You can see the deployment down here is happening, and it's already in there, revision 1. We can go ahead and take a look at the actual API proxy in the Apigee UI. Press the UI. And we should see it there. Just now, there is a new API proxy now called Weather API. And if open this up, it's just a regular API proxy, nothing different than the proxy you would create manually. The only difference is this was generated by the tool. And inside this proxy, we do have basically assigned message policies and few JavaScript policies that basically implement the MCP protocol and have all the information for the tool response that's gonna be sent for this. Basically for this MCP server. If I look at, for example, tools list here, you should see the response. We have message for the tools list response, and it's basically it has actual JSON RPC for the tools list response. And this was all added and generated by the tool that I showed you earlier. All right, so let's go ahead and actually try this. I'm gonna start a debug session. So it's deployed now, and we can use the MCP Inspector for actually rest it. I'm gonna run the MCP. I am going to point to the URL, so just deploy it. So let's go ahead and start the MCP Inspector. That will take only a second. So now that MCP Inspector is running, we should be able to connect to this proxy. So it was MCP server. So we hit connect, and you can see down here, it says, hey, you are connected. So we are good. And next we can do a tools list call. So if you do these tools, you can see all the tools are there. So this is all come from the OpenAPI description that is, I showed you earlier. We can actually try it. So let's run maybe one call for alert query. And let's see if the alert is in this area, which is basically, this is just stands for specific ocean. So let's go ahead and run the tool. And remember, all of those I told you, they from the schema, from the parameters. And you can see now that the actual response is here. And basically this response comes from the MCP server. Or fake MCP server. Actually the API proxy in Apigee. There is actually data that's coming here from the backend REST API for like basic weather information. So you can see in the Apigee debug. So last one here. Let's see. This one here, we should be able to check it out. Let's see. This was tools list call. And the response should contain the tools list. You can see the tools list in here. Now that basically we tested, we have an MCP server that is created. Basically from OpenAPI description. So that's pretty cool. It's so if you did not have stand up a Claude run or create anything with fast MCP or anything like that. But there is more than this. You can actually test this also with Antigravity CLI. I'm gonna show you this as well. So in Antigravity CLI, you can say, hey, I have an MCP server, and then you can give the URI. Or your MCP server. So here I basically just put the URL up, and we should be able to start Antigravity CLI and just basically use the MCP server from the Antigravity CLI. Let's go ahead and start it. So I can do /MCP in here in the Antigravity CLI, and you can see that all the tools that are there in the MCP server are showing up in here. And I can actually use it. Tell me weather alerts in California. And under the hood, Antigravity CLI is going to figure out what tools it needs to use from the MCP server, and in the order necessary based on the descriptions that the tools have, the inputs and the outputs, and orchestrate the calls to give me an answer. So you can see it's already doing those calls, and it's already getting some responses from the MCP server. And it's giving me a natural language response for weather alerts in California. What about Antigravity UI? The same config shared, manual add-in available. And provide your prompt.